This is a multiple-choice question testing my understanding of IncrementalPCA, a technique used for dimensionality reduction in machine learning. I need to select all the true statements about its use with large datasets. It's like a quiz to check my knowledge. I'm dealing with a massive dataset, millions of data points, and I'm using IncrementalPCA from the Sklearn library to reduce its dimensions. That's like trying to organize a huge pile of papers into neat folders, making it easier to find the information I need. The question asks me to identify the correct statements about IncrementalPCA and its effectiveness in this case. This statement says that IncrementalPCA is great for large datasets because it works on smaller chunks of data at a time, not all at once, making it friendly to my computer's memory. This is true and is why I use it for large data. Think of it like eating a huge pizza in slices instead of trying to gobble down the whole thing at once. Here, we are talking about the BATCHSIZE parameter in IncrementalPCA. A smaller BATCHSIZE means that my computer processes fewer data points at once, requiring less memory. However, I'll need to do more iterations to cover the whole dataset, so it takes longer. It's a trade-off between speed and memory. Think of it as having smaller pizza slices. Easy to eat one at a time but more slices overall. The decomponents parameter lets me choose how many important features I want to keep after dimensionality reduction. It can't be more than the original number of features. That's like trying to put more things into a smaller box than will fit. This makes complete sense. The overall scenario is that I'm working with a very large dataset, millions of samples, and need to perform dimensionality reduction using IncrementalPCA, which is from Sklearn library. It is a great tool to process and reduce the dimensions of my large data. This is false. This statement is incorrect. IncrementalPCA is actually designed for large datasets precisely because it doesn't process the whole dataset at once. It's the opposite of what this option claims. A diagram of IncrementalPCA would visually show the process of taking a large dataset as input and splitting it into smaller batches. Each batch is processed in turn to create the model, showing how it handles large data efficiently without overwhelming system memory. The input to IncrementalPCA is my very large dataset. It is a starting point before the dimensionality reduction starts. This highlights the core method of IncrementalPCA. Instead of tackling the whole dataset at once, it divides it into smaller, manageable batches and processes them sequentially. This efficient approach allows the algorithm to handle massive datasets. This step in the IncrementalPCA process uses the batch processed data to reduce the number of features in the dataset, simplifying the data while preserving its essential structure. This helps make the data easier to work with and interpret. I see this parameter controls how much data you feed to the IncrementalPCA algorithm at once. Think of it like eating a large pizza. A small batch size means you eat one slice at a time, less memory used, but it takes longer, while a larger batch size means you eat multiple slices at once, more memory used, but faster. The batch size directly impacts the trade-off between memory usage and processing speed. This one's important. It determines the number of principal components you want to keep after dimensionality reduction. You are essentially choosing the size of your compressed representation. Imagine squeezing a big beach ball into a small box. The in_components parameter specifies the size of that box. It can't be bigger than the original number of features. You can't fit more information into a smaller box. This question asks you to analyze the properties and behavior of IncrementalPCA, particularly its memory efficiency and the roles of its parameters in processing large datasets. You are evaluating the accuracy of several statements describing these aspects. This statement focuses on the n_components parameter. I already explained what this means above. You need to recall that this parameter determines the number of principal components. A principal component is a new variable that captures the most important variance in the original data. The number of such components can never exceed the original number of features. This statement is wrong because incremental PCA is designed for large datasets. The algorithm works by processing the data in small batches, avoiding loading the whole dataset into memory at once. It's like taking a large project and breaking it into smaller, more manageable chunks. This is completely true. Incremental PCA handles large datasets efficiently because it processes the data in batches, rather than all at once. This makes it far more memory efficient than standard PCA. A smaller batch size means fewer data points are processed at a time, reducing memory needs. However, this comes at the cost of more processing time because more iterations are needed. Think of it like assembling a large Lego model. Building it with smaller sets of bricks, smaller batch size, takes longer, but requires less space at once. I see this phrase, and I immediately think about how IncrementalPCA is a special type of principal component analysis, PCA, designed to handle really big datasets. It's like a superhero for data. Standard PCA tries to process everything at once, but IncrementalPCA cleverly breaks the dataset into smaller chunks, which makes it much more memory-friendly. This tells me we are dealing with a massive amount of data, millions of individual data points. That's a lot of information to process. This is why we need an efficient method like IncrementalPCA. This is the key algorithm in the problem. As I mentioned, it's a specific type of PCA built for efficiency when dealing with humongous datasets. It processes the data in chunks or batches. These are parameters we can adjust within IncrementalPCA. The BATCHSIZE controls how much data IncrementalPCA processes at a time. A smaller value means more iterations and more processing time, but less memory. The NCOMPONENTS parameter determines the number of principal components, the dimensions, we want to keep after reducing the data. Think of it like deciding how much detail you need to retain from a complex picture. I see this as the core concept. We're using incremental PCA, a special type of principal component analysis, PCA, designed to efficiently handle massive datasets that don't fit into memory all at once. This is the problem statement. I'm given a big dataset, millions of samples, and need to use incremental PCA to reduce its dimensions. The goal is to identify which statements about using incremental PCA in this situation are correct. This statement is true. Incremental PCA's strength lies in its ability to process data in smaller chunks, batches, preventing memory overload with massive datasets. Think of it like eating a large pizza slice by slice instead of trying to gulp it down all at once. This is also true. A smaller batch size means more batches to process, increasing the computation time. However, each batch will occupy less memory. It's a trade-off between speed and memory usage. This statement is correct. The N_components parameter controls how many principal components, the new, reduced dimensions, you want to retain. It cannot exceed the original number of features in your dataset. This refers to the number of samples processed in each iteration of the incremental PCA algorithm. A smaller batch size means less memory usage per iteration but more iterations to process the entire dataset. This parameter specifies the number of principal components to retain after dimensionality reduction. It's a key parameter in PCA and related techniques, controlling the desired level of dimensionality reduction. I'm using incremental PCA, a technique designed specifically for handling large datasets efficiently. It's perfect for situations where you have millions of data points and need to reduce the number of features. Standard PCA struggles with such large datasets because it tries to process everything at once, leading to memory problems. Incremental PCA cleverly avoids this by processing the data in smaller chunks. This question tests your understanding of incremental PCA and its application to handle extremely large datasets. We're going to evaluate 4 different statements about how incremental PCA works. Let's see if you can identify the correct ones. Let's talk about the batch_size parameter in incremental PCA. A smaller batch_size means you're processing the data in even tinier chunks. This reduces the amount of memory needed at any one time. But, the trade-off is that you now have many more tiny processing steps, which means a longer overall computation time. Think of it like this. It takes longer to eat a huge pizza one bite at a time, but you don't need a huge plate. The _n_components parameter controls how many principal components you want to keep after dimensionality reduction. This is true for incremental PCA and standard PCA. You can't magically create more dimensions than you started with, so this number must always be less than or equal to the number of original features in your dataset. This statement highlights the core advantage of incremental PCA. I process the data in batches. This is key for handling large datasets because it significantly reduces memory demands. Instead of loading everything into memory simultaneously, I work with smaller, manageable pieces. This is a quiz about IncrementalPCA, a technique we use to handle really big datasets in machine learning. We'll explore how it works and what its parameters do. Let's figure out which statements correctly describe how IncrementalPCA handles large datasets. I want to highlight that IncrementalPCA is awesome for large datasets because it doesn't try to load everything into memory at once. Instead, it cleverly processes data in smaller chunks, or batches, which saves memory. Think of batch _size like the size of a bite you take when eating a huge pizza. A smaller batch _size means many small bites, more computation, more time, but less memory needed per byte. A larger batch _size means fewer but bigger bytes, less computation but more memory needed per byte. The _n_components parameter in IncrementalPCA is like choosing how many slices of pizza you really want. It controls the dimensionality of your reduced data. You can't keep more components than the original number of features you started with.